Hi guys, welcome to the last chapter, chapter 12. Can't believe that it's this late in the game here. So congratulations that you've stuck it out. You've really done well. You've put a lot of time and effort into this class, and it's going to all pay off. That's the good news. More good news. I have really gone light on this last chapter. It's a really quite a heavy chapter actually. It's composites, exponential, and logarithmic functions, which are very important. But I think at this point, if you just get a brief skimming on all of the topics, and when I say brief, 7 points in your homework here, really light. I think you guys need to concentrate on reviewing for the final as well. So all of the review problems for the final are now open. So hopefully if I have reduced your homework for this last chapter, that you can take some of that time and review for the final. I have also taken out the quiz and the test for chapter 12 and just dumped this information into the final exam so that you get an extra couple days in there as well to review for the final. All right, the final is cumulative. That means it's over the entire course. Chapters 6, 7, 8, 9, 10, 11, and 12. That's a lot of information. I have given you some really good pointers in the review problems. I will take review problems for your test questions. So if you can get through that review well, you should have no trouble getting through the final. Okay? So I hope that this gives you a little bit of breathing room to get everything finished. So everything will be due by the due date that says on my math lab, and so all of chapters 12's homework and the final exam is all that you have left. The reviews are all optional, but I would highly recommend that you do the final reviews. Okay? All right. So that being said, we're going to move on to chapter 12. Like I said, just super light, just a brief skimming. You'll see all of this stuff again in great depth in college algebra if that's where you're heading. Okay? So this first section, section 12.1, is all about composite functions. All right? Composite functions. That means it's got this little circle in between there. Okay? So what does that mean? Well, we say, the way that we say this is g of f of -4 or f of g of 2. Okay? So we have two functions here. We have f of x and we have g of x. Now, one thing that we haven't seen and we won't see because I skipped all that is that you can add these, you can multiply these, you can subtract these, and you can divide these. But you can also do composites of these. Okay? So when you do composites of these, you're always working right to left on these. All right? So you're going to do, first of all, f of -4. All right? You can get an answer. And then you're going to put that answer into g. All right, so you're always working this way, always right to left. Okay, so let's start. Let's do f of -4 first. All right, so f of x is x squared. So let's look at what f of -4 is. What would we do? We would replace the x with a -4 and crunch out a number. So f of -4 is 16, correct? Now we're going to take g of 16. We take g of that answer. Okay? So now we want to do g of 16. Well, that's replacing in this function x with 16. 16 plus 6. 22. Okay? So the first thing that we do is we go f of this number, evaluate it, get an answer, and then we take g of that answer. Let's see if we did it right. We did. All right, let me just move that down just a scooch. All right. So now what does this tell us to do? Well, it says f of g of 2. Well, again, we're moving right to left. So we have f of g of 2 means take g of 2, get an answer, and then do f of that answer. All right, so g of 2 would be 2 plus 6, right? I'm putting in a 2 here, so I put the 2 there, which is equal to 8. Now I'm going to take f of 8, correct? I want to take f of that answer. So I'm going to replace in this function x with 8. So we have 8 squared, which is 64. Okay? Just these are not difficult, that you just have to really keep it straight which way you're going, what you're doing first, and which piece you're putting into which function. That's the only hard part about it. Now this says g of f of x. Well, that's a little different. Let's see what we got here. We have g of f of x. Okay? What does that mean? It means take f of x and plug it into g. Okay, so we're going to take this function here. We don't have a number, so we're just going to leave it as an x squared, and we're going to put it in there, wherever I see an x, in g. So if f of x is x squared, and g of x is x plus 6, then I take this and I plunk it into that. Okay? So really what I'm doing is I'm evaluating g of x squared. So that would be x squared plus 6. I'm replacing my x with an x squared. Okay? Does that look weird? It should. X squared plus 6. And one of the things with skimming things is that we can't really get into depth on why we need this. Okay? But this is a very valuable thing. And I don't want to get into how it's used and the applications, and there's a ton of stuff that we use this for. But for right now, I just want to, even logs, I'm going to kind of skip the behind the scenes, why we would need a log or an exponential function and all that kind of stuff, because we just don't have time. Okay, and you'll hit that in college algebra for sure. So now we want to do the other way around. We want to do f of g of x. F of g of x. So we're going to take g of x, so we're going to insert it into f, right? So g of x is x plus 6, so that's really what we're evaluating. X plus 6 squared, right? We take the x and replace it with x plus 6, so we're going to be squaring it. Now I don't know how that's going to want that. If it wants, oh, it says do not simplify. Okay, so then don't simplify. That I can do. Kind of like it when it says don't do anything with it, and I go, oh, okay, I can do that. I can handle that. All right? So these are not difficult. It's just which way and what we're plugging into what. Okay? So you've got a whole nother one here. Here's your f of x. Here's your g of x. And should we do these? Maybe we should do these just because they're so brand new for you guys that if you haven't seen a whole lot of them, if you've never done composites, they can be quite tricky. And we have g of x is equal to x squared plus x minus 7. Okay, so f of g of x is taking g of x, this whole thing, and plugging it in right there. Okay, we're inserting g into f. So really what we're doing is we're evaluating g inside f. Okay, so that would mean replace the x with this. The x is here. And then we have the plus 4. Now it tells us to simplify, so we're just going to combine these two right here for negative 3. Okay? F of g of 2, well, now we're actually working with numbers. So what is this telling us to do? It's saying find g of 2, get an answer, and plug that into f. All right, well, we can do that. G of 2 is 2 squared plus 2 minus 7, right? Wherever I see the x, I put the 2. This is 4 plus 2 minus 7, which is negative 1. Now I'm going to insert this into f. So f of negative 1 is negative 1 plus 4, which is 3. So there's my final answer, 3. Oh, are you going to make me put these in here? Darn you. X squared plus x minus 3. That was the first one. This one's 3. All right, so now g of f of x says to take f of x and plunk it into g. So all of this goes there. And it's telling us to simplify our answer. So, all right, so we want to evaluate g at, hello pen, there you are. I lost my train of thought. G at this, right? We want to take the f and plunk it into g. So wherever we see an x, I have to replace it with x plus 4. Okay, so here's my x squared, here's my x, and then that was just negative 7. So wherever I see the x, I'm going to replace it with an x plus 4 instead. Now it's telling me to simplify. All right, well, this is a foiling problem. See, I have another foiling problem again. Always had that foiling problem in my life. First term. You guys should be expert foilers by now. Outside. Inside. Last. Dropping these down. All right, so what do we have here? I've got an x squared, and I've got 8 x's, 9 x's, right? And then I've got 16 plus 4 is 20. 20 minus 7 is 13. And since these three are all not like terms, I'm done. Let's check that one. Plus 9x plus 13. Okay. So these are a lot harder when you're just evaluating at x, because then you're just throwing functions in and you have to simplify algebraically. When you actually have a number, these are quite easy. So this one's saying find f of 2 first. Well, 2 plus 4 is 6. That's really easy. And then evaluate g at 6. So let's evaluate g at 6. 6 squared plus 6 minus 7, right? So you could even, you know, be super lazy, not even think. You could do it that way too. So that's 35. Okay, so that's composites. I think you have one more in here. Yep, you have a denominator, so be careful. And a g of x. I think I'll leave you alone on this. You've got numbers on the first two. You will have fractions, but you can use your calculator for fractions. And then here you're just inserting into generically. So this one you're taking f and putting it into g. This one you're taking g and putting it into f. Okay? I think that should, there's nothing different on that one. And yet another one. Okay, so there's 4 of them in here that you have to practice with. So practice, practice, practice. All right, so these first 4 were the algebraic way of finding composites. Now we can also do it numerically with a table. These are much easier. So we're going to look at that. There's another table, and then we're going to look at it graphically because we have all 3 representations, right? So we did the symbolic, now we're going to do the numeric, which is the table form, and then we'll go on to the graphical. All right, so what is this asking me to do? F of g of 3. That's telling me to take g of 3, get an answer, and then evaluate f at that answer. Okay, so let's do g of 3 first. This is my f of x box, and this is my g of x box. So I'm going to be down here in my g of x because I want to do that one first. So g of 3, that means when x is 3, g of x is 5. Okay, so now I go up to this box and say, well, when x is 5, f of x is 1. So that's my answer. Okay, let's try it again. This time we're going to do f of 2, get an answer, and then do g of that answer. Okay, so I'm going to be f of 2 when x is 2, f of x is 5, and when x is 5, g of x is 1. So they're both 1. See how that works? Let's try another one. All right, what does this mean? F of 6. That means you take f of 6, get an answer, and then you put the answer back into the same function. Okay? So when x is 6, f of x is 9. When x is 9, f of x is 7. This has nothing to do with g of x. Okay, so we're going to do f of 6 first. F of 6, when x is 6, f of x is 9. Now I'm going to evaluate the function in f again at 9. So when x is 9, f of x is 7. Okay? I'm hoping that I'm not confusing you terribly. These can be quite confusing, but they're not hard. All right, last one, graphical. This one sometimes messes people up. But we've got f of g of 1, g of f of 1, and g of 0. All right, we can do that, but I'm going to have to blow this up. I don't need my pad down there anymore, so. All right. So what is this telling me to do? Well, first of all, let's look at the graph. G is the straight red line, and f is the blue parabolic line. Okay? See how that works? This is telling me find g of 1 first. Okay, so that's all we're going to do is just find g of 1, right? Then we take that answer and we evaluate it at f. So let's do g of 1 first. Okay, that means when x is 1, okay, when x is 1, that's right here. What is g of x? G of x is 3, right? I'm looking for the corresponding y value when x is 1. So it's 3. So now I take that answer and I evaluate it at f. When x is 3, what is f? F is -1. Okay, so that's -1. Oops, I can't do both of those at the same time. It won't let me. Okay, let's do another one. G of f of 1, that means take f of 1, get an answer, the y value, and then throw that as your x value in for g and find your other y value. Okay? So f of 1, that means when x is 1, f of x is -1, right? That's the corresponding y value. Now I'm going to go on here and say when x is -1, g is 1. So your answer is 1. Got to close that, sorry. Okay? G of 0. Ooh, okay. We first of all find g of 0, get an answer. When x is 0, g is 2. Okay, now I throw that back in for my g again. When x is 2, g is 4. So g of 0 is 4. Now if this didn't make any sense, or it was quite confusing, these last little bits, replay this video, okay? That's my suggestion to you because they're all done the same, so just keep trying to follow what I'm saying here. All right, and that's it for for section 12.1. So, you know, like I said, I'm keeping these super light. I think it's 10 points would probably be the max on some of these homeworks in through here. So, all right, I will see you for 12.2.